Good morning, this is Tehmeena Khan. This video is number 4 in the continuation of sampling and estimation, which is a topic of A-level mathematics S2 CAIE exam. So in the last video we covered unbiased estimate of population parameters and we started confidence interval, but we did not complete all the aspect of it. So in this video we will see more examples on confidence interval. So before I start, this is the blog address of mine. All the videos which I have uploaded on YouTube so far, the link of those videos is available here. So it's a quick access to the videos. So let's go and continue what is confidence interval and how it is applied in different situations and how do we calculate it. Okay, so this question is taken from Croshaw A-level concise statistics and it is exercise 9E question 6. So it is related to width of the interval. So we will see here what is the meaning of width of the interval. Now for example, a random sample of 6 items is taken from the normal population. Mean is mu and variance is 45. So you don't know mean. And sample values are these. The 6 values, the 6 items of the sample, the values are these. You have to find out the critical region or the end values for this sample so that you're 95% sure that your mean of the population will be lying between those two values. So this is what you will calculate. And second part, it is about the width of the confidence interval, which we will see later. So let's first focus on 95% confidence interval. Now we know the formula of the confidence interval. Can you tell me what was the formula which I just showed you in the previous video, giving you just 15 seconds to think about. So the formula was, if you have recalled, you can write on the paper and let's see you recall it correctly or not. So it was x dash plus minus z sigma over root n. So now mostly students get confused what to write in place of z, what value. If it is written 95%, usually they just read from the table, z standardized table, 0.95. The z value against 0.95, which is not correct. Reason is 95% confidence interval mean it is exactly in the center, 95% probability, right? So what is remaining probability? 5%. It will be divided equally on both ends, which is 2.5% and 2.5%. So when you will read the value, cutoff value, the critical value here and value here, you will not read against 95%, you will read against 97.5%, which is 0.975, and that will be your z value here, and the same with the negative sign here. 97.5 because this is 95 and this is 2.5. Z table always calculate the probability on the left hand side of the boundary, whatever boundary you are taking. So let's see from the question what information do we have, and then we will look for the confidence interval. So x, we are talking about the length, right? And the population parameters are mu, variance. Variance is given to you 4.5. And then for the sample, your distribution will be x bar, the symbol for population, mu comma sigma square over n, right? And n is your 6. And we know that if my population is normal, the sample will also be normal. So let's calculate a confidence interval. The formula will be given to you. Okay, so the formula is x bar plus minus z sigma over root n, and I have just taught you how to calculate z. It is here 1.96 for 95% confidence interval, which we read against 0.975, right? And now we have to calculate mean. Why? Because the raw data was given to you, mean was not calculated for you. So you will add up the data, divide by 6, you got your mean. So now you know this value, you know z value, you know sigma, it was 4.5, and you know n, it was 6. So I'm plugging in these values here, and after plugging in the values, the minus or the smallest value this side is lower bound, lower limit, or cutoff value, critical region, all this you can say. And once you get after plus, it is called upper limit. The second part of the question was asking, just a minute, I'll show you the question again. So the second part of the question was saying, what is the width of this confidence interval? Now we know that width means from here till here. This is called width. So I have to calculate this width. If I know this value and I know this value, I can do what? Simple add them up and find out the width, right? Or no? Yes, we can. So let's see how we will calculate the width of the confidence. So we know from the confidence interval formula that mean is exactly in the center. This side it is x bar minus 1.96 sigma over root n, and this side it is z sigma over root n. So this and this together from here till here, it will give you width of the confidence interval. So it means that from the formula, which is x dash plus minus z sigma over root n, this portion is actually representing this length, right? This length. So from the mean value, when we subtract this length, we get this boundary, and in the mean value, when we add this length, we get this boundary. So basically double of this gives you the width of the confidence interval. And question was saying, what is the width of the confidence interval in this case? So it is 2 times z root sigma over n, and you are calculating it and you found it 3.40. So I think in a while ago, just by mistake, because of slip of tongue, I said these two values you will add up. No, you will subtract these two values to get the limit. So we got in the previous answer this value as 14.15 and this value here as 10.75. So if you subtract these two values, 14.15 and 10.75, you will get the same answer. So this is how you calculate the width of the confidence interval. Now let's see past paper questions on confidence interval. So first of all, I am talking about the question in which the normal distribution is given, variance is known, and sample size is any, because when it is the population is normal distribution, the size does not matter, the mean distribution will be normal. So this question I have just printed here, and it is from November 10, variant C3 and question 3. So the question says, okay, so the question is about sweets produced in a machine, by a machine, and they are normally distributed, and the mean of it is mu, so mean is not given to you, and standard deviation is 1.0 gram, and you are taking a sample of 65 sweets by the machine, and their mean is 29.6. So far in the first paragraph, the information given is about that your random variable is the mass of the sweets, and it is normally distributed, mean of the population is unknown, and variance 1.0 is given to you. Now you are taking a sample of 65 sweets, and when you calculate their mean, it is 29.6. So you have to find out 99% confidence interval for mu, which means you will find out the mass of the sweets, upper bound and lower bound, that you are 99% sure the mean of the population will be lying between these two values, right? So let's see how we will do, and then we will read the remaining part of the question. So X is the mass in gram of sweets produced by the machine. So your normal distribution is mu comma 1.0 square. Your n is 65. So sample mean distribution will take this shape, right? We have studied in the previous videos also. So x bar for normal is mu comma 1.0 square divided by 75. So this is the distribution, and now you have to calculate 99% confidence interval. Okay, so the mean of the 65 suits, the sample size is given to you 29.6. You have to calculate 99% confidence interval. So the formula is x bar plus minus z sigma over root n. Now I'm repeating, mostly students make mistake in writing the value of z. Because they read 99%, from the z table they read 0.99 and get the what? Z value against it. But no, you know what you will read? Because it is 99% here, 1% is remaining, which is 0.5% this side, 0.5% this side. So when you are calculating this z value, from the table you will read 99.5%, because 99 here and 0.5 here. So for this 99.5% you will read what? The answer is coming 2.576. So you can check your understanding. Take out the table and see is it 2.576 or not. And after that, one time you are adding in it and one time subtracting. So it is giving you your upper and lower limit. It means the suit produced by machine will, the population mean will be lying between 29.3 gram and 29.9 gram. Right? Let's see what was question 2 asking now. Okay, so part 2 is saying that manufacturer claims that the sweets produced has a mean mass 30 gram. So if you have already found your confidence interval, the answer was 29.3 and 29.9 gram. So what conclusion do you draw about this claim based on that interval? Does 30 lie between 29.3 and 29.9? If it does not lie between these two end values, it means the manufacturer claim is not correct. But if 30 lies between it, then it means manufacturer claim is correct. So what do you say? How will you write? It's very simple. Since the end limits are this, and if you can recall number line in your mind, 30 does not come between these two values. So you will simply say the confidence interval does not contain 30, so the manufacturer claim is not supported. Okay, so this is how you will write. It's just 1 mark question. Let's see what is part 3 saying. Okay, so the last part of the question is saying that another sample of 65 suit is taken, right? And after that 99% confidence interval was calculated, and this time the conclusion is different. In part 2 we concluded that 30 does not lie in the interval, so manufacturer's claim is not valid. But here the question is saying that this time the conclusion from that found in part 2 is different. So this time the conclusion is different. It means now you are accepting the claim. So question is saying, assuming that the value of mean has not changed, explain how this is possible. How come it is possible that now the manufacturer claim is correct? Because it's a new sample. So what do you think? Giving you a few seconds. Meanwhile, I'm going to the solution of it. Okay, so here is the solution. Basically, it is a statement. Because the question was saying that now the claim or the conclusion is different, it means you are accepting the claim. So as the claim is supported, the confidence interval constructed from the second sample must contain 30. It means the confidence interval will be more than 30 and less than 30, so that 30 comes in between that range, right? Within that range. And every time we take a sample, it gives you different values, not exactly the same values, right? So now that sample you have taken and calculate the confidence interval, it will include this. So you can say confidence interval will vary according to the values of the sample mean. because the question was asking how it is possible. So you have to explain that because the sample size will vary, will make confidence interval vary, and that's why population mean will lie between the range, right? So this is how you will explain. Now let's take a case of the confidence interval when population is not normal and you don't know variance, but sample size is very large, which is greater than or equals to 30. So I have picked up a question from November 14, variance 7.3 and question 3. So the question is saying the time in minutes taken by people to complete a work. So it's all about people completing a work, and it is normally distributed. So you are told that the population is normal, right? It may be normal or may not be depending on the question, but in this case it is normal distribution, normally distributed. And question is saying the sample of 80 people is taken and the data is summarized like this. So you are not given here the individual raw data, rather summarized form is given to you. And you have to calculate the confidence interval for mean. Now 97% mean, total 3%. So 1.5% will go here, 1.5% will go here. And now I will calculate the z value against 98.5%, because 97 plus 1.5 is 98.5%, 0.985. So your z value is coming 2.17. Okay, you can read from the table. Now the data, summarized data, is already given to you in the question. So if you have to calculate mean, because it is needed in the confidence interval formula, this is the formula. So to calculate the mean of t, you will do what? I will explain on the next page. It is sigma t over n, right? And I'm not writing here this value of sigma. Can you notice? I'm writing this value of a standard deviation. Why? Because this represents population and this represents sample. In the question we are not given the value of the sigma, population variance. Are you getting my point? So when it is not given, the symbol will change. So t bar you will calculate how? You will calculate sigma t over n, and my n was 80. So 7220 divided by 80, that value will come here. Let's see the rest of the values. So here we have calculated the value of mean, 7220 divided by 80, which is 90.25. Let's see how we will calculate the variance, unbiased estimation of the variance, because population variance is not given. Now this is the formula which I have told you earlier also, is given to you in MF9 also, and you can learn it by heart as well. And you will plug in the values in it. So n is 80, 80 minus 1 is 79. So let me show you the substitution, but I'm just writing here before that another formula. Both will be given to you in MF9. You can use any, whatever you like. So let's substitute the values in this formula. It is given below. So I have plugged in the values here. It is all given in the question. Sigma x square, sigma x, n. So I got this answer. So this is my, what is this? Do you remember what is this? This is your unbiased estimation of variance, right? Because you don't know population variance. Now let's apply the confidence interval formula, which is x dash plus minus z root q over n. So everything is already calculated. So now we have applied here and we will calculate it. So after calculation you are getting these two answers, right? You are getting these two answers. The last part of the question is saying, explain why it was necessary to use the central limit theorem. Either it is necessary or not, right? Whether it was, not why. It was whether it was necessary to use central limit theorem. So do you remember in which case we use central limit theorem? Yes, when it is non-normal population and the sample size is big enough. So to calculate the probability, you can say I am applying central limit theorem and hence I will use approximate normal wala case, right? So you will say no, it was not necessary to use the central limit theorem. Why? Because population was normal. If population was not given normal, then you will say yes, it was necessary, and because the sample size is large enough, greater than 30, so we can use central limit theorem. But right now it is not necessary because आपको तो population normal दिया हुआ था, right? So at this I will finish my video because the length has gone up to 20 minutes. Thank you very much for watching the video. If you like it, if you learned something, so please press the like button and subscribe button and bell, so that when I upload my new videos you can get the indication. And if there is any suggestion, you can write in the comment box. Once again, thanks. Bye bye. Allah Hafiz.